box jelly, irrikanji, has such potent venom that they are easily capable of killing humans. Also, most of us have experienced sticking our finger in an anemone and have felt that bizarre tingly feeling. We ask ourselves, what is happening on a cellular level? Nematocysts, stinging cells, are present in virtually all cnidarians. The phylum Cnidaria contains over 10,000 aquatic species. Cnidaria is comprised of 4 main groups: sessile anthozoa, i.e. corals and anemones, the swimming scyphozoa, jellyfish, cubozoa, which are box jellies, and hydrozoa, which include the colonial cnidarians. All of these creatures have nematocysts located on their tentacles. Nematocysts function as both a defense mechanism and as a means to get food. Let's go check out some anemones. This anemone, each tentacle is home for thousands of nematocysts. As I stimulate the animal, the specialized stinging cells fire. The tentacle feels sticky, but actually isn't stinging me. The skin on my finger is too thick for the harpoon to cross. Most prey items, and also most predators, have a thin epithelium that the spear-like appendage has no trouble shooting through. If you want to experience getting stung by a local anemone, you can let the animal sting your tongue. Anemones have evolved to feed on mainly invertebrates, like mussels, crustaceans, annelids, with an occasional vertebrate like a small fish. In this illustration, you can see the tentacle of a cnidarian. All of those little circles are stinging cells, nematocysts, ready to strike. In real life, there's thousands and thousands that sit just beneath the epithelium. The nematocyst itself is coiled up inside an explosive cell, or capsule, called a nemocyte, or a netoblast. The nematocyst is charged and ready to fire instantaneously. Upon stimulation, the nematocyst uses its stored, pressurized energy to discharge out of the cell. The hinged operculum opens as the nematocyst threads exit the cell. The operculum works as a door between the netoblast and the opposite side of the epidermis. Stimulation is triggered by a prey item or a predator coming into contact with a small, hair-like appendage located next to the operculum. This appendage is called a cnidocyl. Once expelled, the nematocyst thread exhibits a series of barbs used to pierce the skin and hook onto the target organism as it injects venom. This stylet blasts out of the capsule at an average velocity of 2 meters per second and takes about 10 nanoseconds to discharge. Here's a clip of nematocysts firing. I think it's crazy how such small, innocent-looking animals with their soft, squishy mesoglea can have such deadly harpoons firing from the epithelium. Box jellyfish are known as the most venomous sea creature because of their extremely potent venom. One sting from a box jelly can kill a human in less than 5 minutes, and one jellyfish contains enough venom within its stinging cells to kill 60 adults. Another interesting fun fact is that jellyfish nematocyst venom is pH sensitive. The physical process of the nematocyst firing seems unharmed, but the venom itself appears to be affected by a changing pH as well as a changing temperature. The chemical compound won't work the way it's supposed to as environments change. Chemical reactions change as the venom becomes denatured. Both global warming and ocean acidification are lessening the effectiveness of a jellyfish's venom lethality. Many species of jellyfish will have difficulty hunting with a surplus of hydrogen atoms. Nematocyst venom contains chemical compounds that exhibit hemolytic, cytolytic, cardiotoxic, neurotoxic, muscular toxic, clastogenic, and enzymatic properties. This means that the venom of Cnidaria is capable of destroying red blood cells, stopping the heart, disenabling the communication between neurons, and incapacitating muscular function. The venom found in anemones and jellyfish has very similar properties to Botox, which is a neurotoxin. Just as Botox paralyzes muscles to prevent wrinkles, Cnidaria venom paralyzes its prey, so locomotion can no longer be used as an escape route. Just as a clarification, venom is different than poison. Venom is injected via a bite or a sting, and poison is something you eat. Just as you wouldn't say that a mushroom is venomous, you also wouldn't say that nematocysts inject poison. That being said, even though they're not poisonous, you still shouldn't eat a jellyfish or an anemone because it can sting you on the way down, as nematocysts fire. I really hope you think nematocysts are as cool as I do, and I hope you've enjoyed learning about their function, physical and chemical properties, and how important they are for cnidarians.